Assalamualaikum warahmatullahi wabarakatuh. Before I start, I would just love to introduce myself first. I am Anindya Zilka Qisthi, coming from Prominent High School of MH Tamrin. I'm sitting at 10th grade currently, and today I will be discussing and uncovering a question from the topic of DC circuit and electricity. So without any further ado, I guess let's just get started. Okay. Starting at number 1, from number 7, is state Kirchhoff's first law. All we have to do here is to just restate the first law from Kirchhoff's, which is, which is the sum of the current in which enters a junction will always be equal to the sum of the current coming out of that junction. Yeah, there you go. If you would like a visualization, say we have this and the current goes here, and then you find a junction in which divides into 3, and it just goes and goes and goes, and then they reunite here. The amount of current that goes here will always be equal to the amount of current in which goes here. That's practically it. Okay, so Kirchhoff's first law mentions how the sum of the currents, so it's talking about currents, and what's the SI unit for current? That's right, ampere. So the answer should be ampere. Let's move on to B. 3 cells of electromotive E1, E2, and E3 are connected into a circuit as shown in the figure. The circuit contains resistors of resistances R1, R2, R3, and R4. The current in the different paths of the circuit are I1, I2, and I3. The cells have negligible internal resistance. Use Kirchhoff's laws to state an equation relating I1, I2, and I3. Okay, so Kirchhoff's first law basically just states the current that comes in equals to the current that comes out. Let's see here. Okay, the junction is here, guys, and let's try to find which one goes into this. That's right. If we look at here, I3 will just go here. So the current that goes in, let's see, it's I3 equals to the current that comes out here, and there's also here, so the current that comes out is I1 plus I2. There you go, the equation. Okay, so moving on to question II, which we are told to state the equation relating. Okay, wait, let me erase this. I was experimenting. Moving on to the next question, in which we are told to state the equation relating to E1, E3, R1, R3, R4, and I3 in the loop of W, X, Y, Z, W. So if we look at the loop that the question is requesting, it starts from W to X, in which it starts from here, 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 and here. So this is the direction we are going to. Right. Okay, So if you guys remember the formula of sigma E plus sigma IR equals to 0. Yes, we are about to use that formula. So starting from the point W, going upwards here, because you know WX, hey, we meet E3. Except we meet to the negative part of E3, in which instead of just writing E3, we will write down minus or negative E3. And then if we continue to Y and then to Z, we'll also meet E1, but also in its negative form. So negative E1. And now let's look for the IRs. From W, we are about to find I3, I3 with R3, so it would be I3, I am so sorry, it would be I3, R3, and then we will also stumble upon I1 and R1. And R1. And there we go. There we have it. That's the equation. So it appears I might have been a little goofy and I missed a part. So we don't stop here. We can simplify it further to negative E3 minus negative E1. So I forgot to add equal to 0 in the back. So let's shift it to become this. So we'll have negative I3 R3 plus negative I1 R1. And then let's get rid of the negatives here. And there we have it. Yay. Okay, now this is the answer, I suppose. Okay. I hope you find this simple, short explanation of mine helpful. I really appreciate the time and attention you've put for this video of mine. I truly apologize if there was any mistakes that were made in this video. It was all on me. And thank you so much. Bye bye. See you.